Hello everyone, welcome to DataCraft, your go-to place for all data engineering things. If you are new here, don't forget to hit that subscribe button and click the bell icon to stay updated with our latest video. The first video in a 10-minute series with introduction to data engineering focus on evolution of data engineering roles since the inception of computer technology. So let's get started. Let's start by taking an example of banking industry in the early 1960s. How they tried to use computer technologies to store data. It all started with figuring out how to centrally record and report customer transactions such as deposits, withdrawals, and account balance. So at each bank's branch, there will be a bank teller who will typically capture those transactions on a storage device known as punch cards, which are basically a paper cards that are punched with punching machine by bank teller to represent some data like account holder's name, number, balance, and so on. Later, at the end of the day, the punch cards are sent to a central processing station where those punch cards are read through a punch card reader and prints it as a report to keep a record of it. After that, the printed reports piled up, making it harder for bank executive to manage them centrally. As a result, they began to look for a next generation data storage technology such as magnetic tapes. Instead of printing the report, they began to centrally store the data in magnetic tape. In those days, there is no single shot role like a data engineer. Instead, they were called as data processing engineer, who helps in building and maintaining those hardware and software components that are used to store data. That includes right from the designing punch cards, punch card readers, magnetic tapes, and so on. As data size grows, they encounter the issue of the greater utilization of magnetic tape storage. Furthermore, data is often saved as a file storage system, such as storing files in folders and subfolders, which we typically do in our Windows operating system, which lead to some of its limitations like retrieving data from file storage system can be complex and time consuming, as data is scattered across multiple files and may require manual integration. Lack of data consistency as well. Banking operations were typically manual and paper-based in 1960s, with limited use of computers. However, there was a considerable trend towards computerization in banking business in the early 1980s. Bank began to use computer systems for a variety of activities, including transaction processing, account administration, and record keeping. For example, a bank began to expand its customer service by offering online banking, credit and debit cards, and bank tellers began to use mainframe terminals instead of using punch cards for data entry operation. Later, by running mainframe servers, each of these transactions was centrally automated, which are the first generation computers having operating system. Above that, applications for managing those transactions are created using programming languages such as COBOL and Fortran. Further, this is the time that gives birth to a development of relational database management system, which are applications developed to store and retrieve data efficiently. And also, this is the time the role of database engineer evolved, and they were more focused on design and development of applications to exchange data across systems, storing and retrieving data efficiently. This leads to an increased automation and efficiency in banking operation, reducing manual error and speeding up process. In 2000s, mainframe servers were not entirely replaced by a single shot technology, but rather the banking industry underwent a gradual shift towards newer technology that complemented or replaced certain aspects of mainframe system. For example, banks started to expand their service by providing mobile banking and payment services for e-commerce web application, expanded their ATM networks, while bank tellers started to use multiple computer applications for cash handling, customer services, account maintenance, etc. Behind the scenes of this application, there exists an adoption of multiple web-based technologies via internet, an adoption of client-server and service-oriented architecture during the design stage of those applications. Further, as more an application started to generate data, data warehousing and business intelligence technology gained prominence in 2000s, allowing banks to capture, store, and analyze large volumes of data from various sources to gain insights and make informed business decisions. As a result, the function of data engineering continued to evolve over the time period towards the creation of ETL pipeline for data warehousing and business intelligence.
There has been a considerable shift away from mainframe servers in 2020s. Banking industry started to opt for more cost-effective, distributed, and flexible architectures that leverage cloud computing, virtualization, microservices, and other open source software. For example, bank began to give some self-services to its client via internet and mobile banking rather than visiting a branch. And they then began to experiment with more futuristic services such as giving digital wallets via blockchain technology. With the rise of technology, the position of bank tellers have shifted substantially towards a more customer-focused profession, requiring more technical expertise and customer service and sales abilities, and the capacity to manage sophisticated financial transactions. As the amount of complexity of data collected and used by business increased significantly in 2020s, the function of data engineering continued to evolve. The transition from traditional on-premise data storage and processing to cloud-based solution was one of the most significant shifts that occurred during this time period. Data engineers were responsible for building and implementing methods to manage data in cloud environment as cloud computing grows more popular. Working with variety of cloud-based tools and technologies such as data ops, big data, and delivering data pipeline for ML and AI application became day-to-day tasks for current data engineering roles. Thank you for watching it. If you found this video helpful, give it a thumbs up and share it with your friends. And don't forget to subscribe for more content like this. See you in the next video.